Hello students, good evening everyone. Welcome to the physics session. In this session, we discuss basic mathematical tools of physics. We revise quickly, especially the differentiation and integration with few relations. So open your physics books. Okay, so we'll discuss briefly few examples of differentiation and integration. Okay, this kind of revision, brief and quick revision. So all possible rules. I'll give you a few questions also. You can practice along with me. First, let us start with differentiation. So, discussing basic mathematical tools of physics. Basic mathematical tools. Mathematical tools of physics. As part of this, we are going to discuss briefly differentiation. First, we will discuss briefly differentiation. Right? So already we have discussed what is the meaning of differentiation. Those who have joined newly, just we can already, I hope you have copied the notes. Just you can go through that, and whatever the questions we are doing now, again practice these questions, so that those who are copied already also try to copy and practice this, so that it will give you an additional practice. Okay, so differentiation means, in one way, if you compare actually differentiation and integration parallelly, if you observe, integration is the reverse process of differentiation, or differentiation is the reverse process of integration. Usually integration is called as summation or addition. So it is the reverse process, means it will be what you call splitting process. In one context you can see. But actually in physics point of view, if you are trying to find the differentiation of one parameter with respect to another, means change in one parameter with respect to another. Change in one parameter or one quantity with respect to another gives differentiation. Or especially in case of graphs, if you are drawing a graph like a displacement time graph, velocity time graph, like that. For example, I am telling, if you observe the graph, then in case of any graph, like slope of the curve or graph will give you differentiation of one parameter with respect to another. Say for example, if you have displacement S and time t graph, if a body is covering equal displacements in equal intervals of time, starting from t equal to 0, then you will get a straight line. That means if the in 1 second it covers 1 meter, next 2 seconds it covers 2 meters, 3 seconds 3 meters, like that. Then if you consider this data, you will get a straight line. Slope of this straight line gives slope. Slope is equal to, between the initial and final points, if you observe, this is a change in y coordinate by change in x coordinate. Change in y coordinate is nothing but change in displacement, delta s, and this is delta t, or you can also write it as ds. If the change is very small, then this change can be expressed as ds. If the change is a little larger in value, then we express delta s. Difference between delta and d notations we use usually to to represent a little larger value, a larger difference and a smaller difference. Similarly, instead of using delta t, you can also use dt also. So slope is nothing but change in y coordinates by change in x coordinates. This is represented as ds by dt. So this gives the slope. But this ds by dt is also called as velocity. So especially in physics, why this differentiation is useful is especially to find velocity if you know the displacement as a function of time. If displacement is varying with time, then if you differentiate this with respect to time, you will get what is this slope is also called as velocity. In this kind of scenarios, we use this. But right now, we will not go into the physics examples. Only we discuss mathematical related formula and examples only. Okay. So, the meaning of differentiation is change in one parameter with respect to another gives differentiation of that first parameter with respect to the second one, or is called differentiation. Simply you can say change in one parameter with respect to another is called differentiation. It's called differentiation. This is one way I am telling. You can define in different ways. This is one way understanding what is differentiation means. So if you know a parameter y, then y is a function of x. Then differentiation of change in y with respect to x can be expressed as d by dx of the function of x. So this d by dx is called differential operator. So depending on the function which we are differentiating or finding the change, then we will get different values. So now let us see some different functions. How to find the differentiation of different functions. Okay? I will copy this. Now let us see. Let us try to recollect back quickly the formulae, the differentiation formulae. So we have discussed about differentiation of first one is a constant function. Actually constant means we cannot use the word function. A constant, differentiation of a constant. Constant means which will not vary with any variable here. Which will not vary with the variable with respect to what we are finding the change or differentiation. So that quantity can be called as constant. The constant can be any number. If you are taking x is what do you call it? If you are taking the differentiation with respect to x, then some parameter t can be taken as constant. Okay? So that you can understand with the help of some examples. So can I erase this? Let us see first few relations or formulae, general formulae. First one is differentiation of a constant. If y is equal to constant, it can be expressed as some c or k, a, b, c, any number, any value, constant. Then differentiation of y with respect to x. If you have given y is equal to c, or that c may be constant means you can say any number. See, y is equal to 5. Find dy by dx. Differentiation of y with respect to x. Find dy by dx is the question. So what does it mean change in y with respect to x? What is y equal to constant means is you have to understand with respect to a graph. This is your x, this is your y. Y is equal to c. So that means let us say maybe for example this 5. Y is equal to 5 means if x is equal to 0, y is equal to 5. X is equal to 1, y is equal to 5. X is equal to 2, y is equal to 5. X is equal to 3, y equal to 5. That means y will be constant. That is the meaning of y equal to constant. Y will not change with the change in x. Then change in y by change in x will be taken as this dy means y2 minus y1 by x2 minus x1. y2 minus y1. Here y is nothing but 5. So 5 minus 5 by, so you can take between any two parameters, at any two positions. 3 and 2 if we take 3 minus 2 by 3 minus 2. But 5 minus 5 is 0 by 1. You get 0. This is the meaning of differentiation. Differentiation means change. Differentiation means change in one parameter with respect to another parameter. Here as y is constant, change in y with respect to x is 0. It is not changing. Change in y with respect to x is 0. That is the meaning of differentiation of a constant is 0 means. The meaning is clear. So if you get clear about the concept, no need to even by heart. But with some relations, we will not discuss about the derivations, how to get those things. So for example, differentiation of some log function, like exponential function, we will take some formula, we will not discuss in detail how to get those things. Okay. So directly we use some relations. The next one is, if you have a polynomial function, we also call it as a power function. That is, if y is equal to x power n, if y is equal to x power n, then dy by dx is given as n into x power n minus 1. Dy by dx is equal to d by dx of x power n. It is equal to n into x power n. Okay? And another one, this is polynomial function we call that. Differentiation of constant 0. You have to simply remember that differentiation of constant is 0. Then differentiation of power function or polynomial function is the power into x power n minus 1. Then if you take a logarithmic function, if y is equal to log x. Log x means usually we will take base e, but we will not mention that here, but you have to remember that it should be base e. Then dy by dx is given as d by dx of log x is nothing but 1 by x. 1 by x. Is it clear? Whereas if your function is exponential function e power x, if y is equal to e power x, then dy by dx can be expressed as d by dx of e power x is equal to e power x only. If you differentiate the exponential function with respect to x, the same function will get. Got it? Whereas, let us see few trigonometric functions. Say, if, let us say, fifth one, y is equal to sin x. Directly, let me give you the formula. So, d by dx of y place, let us take sin x. It means it is your y. D by dx of sin x is cos x. So if there is no sign, means you have to think that it is plus cos x or positive cos. Positive. D by dx of sin is cos x means plus cos x. Whereas d by dx of cos x is minus sin x. Minus sin x. There is no sign, means you have to think that it is positive. Okay. Then d by dx of tan x is, do you remember? Secant square x. Secant square x. And d by dx of cot x minus cosecant square x. Very good. Minus cosecant square x. These are few trigonometric functions. Differentiation of few trigonometric functions. Power function or polynomial function, log function, exponential function, etc. Okay. While differentiating, we make use of all these formulae along with few general relations. We call them as some rules. Product rule, quotient rule, chain rule. Most frequently we use these rules. Product rule, quotient rule, chain rule. Let us see what are those rules and let us try to work out few examples also. Okay? Yes. Can I erase this? Everyone? So try to note down quickly along with me simultaneously. Right? Let us see first product rule. Product rule. Product rule. Product rule. Product rule says, let us say first, it says that if you have two functions which are functions of x, that is, if u comma v are functions of x, functions of x means u is equal to u of x, v is equal to v of x also can write. So that means what does it mean as a function of x? You can understand by doing the examples. Means u, say for example, is equal to x squared, v is equal to log x. X square is a function of x, log x is a function of x, like that. Or sin x, any function you can take. Both are functions of x. Then I can say both are functions of x, and y is equal to u into v you have. U into v. So product of two functions of x you have. Then dy by dx. Then dy by dx is given by d by dx of u into v is equal to, you have to remember this formula as first function as it is, you have to take u into, then you have to differentiate v because that's partial differentiation. Then so it is u into dv by dx. Then plus, while taking the product rule you have to take plus. Plus second function as it is into du by dx. Du by dx. Right? This relation is called product rule. If you have two functions, u and v, which are functions of x, and if you have y is equal to product of those two functions, then differentiation of that product is obtained by using this. Let's do some few examples here itself, then we will discuss quotient rule and the chain rule quickly. So here, let us consider one example. If y is equal to x square sin x, then find dy by dx. So options will be given. You have to understand how to find this. Whenever you come across this, first select which is u, which is v. Anything you can take no problem. Let us consider first one is u, second one is v. So here u is equal to x square and v is equal to sin x. Select which is u, which is v. Then find out du by dx and dv by dx. Are you following? Du by dx is equal to what? D by dx of x square. So x square means you have to use power rule. Power rule is a d by dx of x power n is n into x power n minus 1. So here in place of n we have 2. So 2 into x power 2 minus 1 is 1. So 2x. So directly you can take. So already you have practiced some examples. That's why I am giving you directly now. So du by dx is 2x. Then v is sin x. So dv by dx of sin x is differentiation of sin x is cos. So you can take directly cos x. Now substitute in this formula u dv by dx plus v du by dx. Then you will get the final answer. That's it. Okay. So therefore that implies dy by dx is equal to d by dx of what is this? X square sin x. d by dx of x square sin x is equal to x square u into dv by dx. dv by dx is cos x. X square cos x plus v into du by dx. v is sin x. du by dx is 2x. So cos sin x into 2x can be expressed as 2x sin x also. This is your answer. You may take x common and you can write x common into x cos x plus 2 sin x also can write. Depending on the options, you have to simplify further. If this is the option, you can keep as it is. If in the options x is taken common, then you have to take this common and you have to check which is the what you call compatible option. Got it? Yes. Note down this. Finished? Next. This is how you have to make use of uv formula. In place of this, you can have sin x log x also, or e power x into x square, or e power x log x, or 2x plus 1 into x square. Both the x functions only you can have. One you have to take as u, another one you have to take v. Okay, I will give you a few examples. First, we will discuss like what you call different rules. Then you can see few more examples. Next rule, write down quotient rule. Quotient rule. Quotient rule. Quotient rule. Right. Under quotient rule also we consider two functions of x. That is, if u and v are functions of x and y is equal to u by v, instead of u into v, u by v, then find dy by dx will be the quotient. In such case, we have to use quotient rule. Can I erase this? Then quotient rule says d by dx of u by v is equal to d by dx of y is u by this y is u by v is equal to this v which is in denominator. You have to take this function as it is and you have to square it while using quotient rule. Okay? And the same function you have to take as it is, the function only, into, you have to take differentiation of u, du by dx, then minus you have to take, minus u into, first function into, differentiation of the second one, that is v, that is dv by dx. This formula is called quotient rule, or differentiation of u by v. This is also called as u by v formula. Product rule is called uv formula. Sometimes we call product rule as uv formula and quotient rule as u by v formula. This can also be called as u by v formula. U by v formula is given by, for differentiation, d by dx of u by v is equal to, when u and v both are functions of x. Got it? How can you use this? We will do one example. Example. If y is equal to x square by e power x, then find dy by dx. dy by dx is equal to what? If y equal to this, then dy by dx is equal to what? Here y is this. One function of x, this is another function of x. Let us consider this is u, this is v. Then what you can write? D by dx of x square by e power x is equal to u v. Separately you can write just like in case of u v formula. U equal to what? V equal to what? And du by dx is what? dv by dx is what? Then you can substitute in the formula. So for that purpose, let us write separately what is u, v, du by dx, dv by dx. There what is u? Let us take u is equal to x square. Then what is du by dx? 2x. By using power rule or differentiation of polynomial function. So 2 into x. And v is equal to e power x. So dv by dx is also e power x only. Differentiation of exponential function gives the same function. Is this clear? Don't have chalk. You are feeling little faster? You are going fast?
Little faster.
Right. See. Yes, because in 30 minutes you have to finish this, then you have to revise integration also. So you have to be little quick. Okay. So d by dx of x square by e power x. If you consider u first, numerator function, denominator function. Numerator function is u and denominator function is v. Then du by dx is this dv by dx is this. If you substitute in this formula, directly you can get now. So what is this formula actually? You get in the u by v formula, v square in denominator. V is e power x whole square. E power x whole square can also be taken as e power 2x. Okay? Then v as d is e power x into du by dx 2x. So I can write 2x into e power x. Okay? Minus u into dv by dx. U is x square. dv by dx is e power x. So minus x square e power x. That's it. This is your answer. Here you can take x square common or e power x common. If you e power x common, if you take here one e power x may get cancelled. So depending on the options, again you have to simplify further. So this can also be expressed further as by taking e power x common, you can write 2x minus x square by e power x whole square. Means e power x into e power x. So one e power x will cancel. So you get 2x minus x square by e power x. So this is also equal to 2x minus x square by e power x. Okay? So this is how you can use quotient rule or u by v formula. Right? Finished? Can I give one more example? We'll do based on even what is that? Chain rule. We'll discuss first chain rule. Then UV formula, U by V formula can be done by using chain rule also. Okay? That first. So first we'll discuss chain rule. Then in terms of chain rule we'll do both UV and U by V formula. Now write down next subheading chain rule. Chain rule. Chain rule. So chain rule says the general formula will looks in one way, but while doing the examples it looks very easy. But if you say if we have y is equal to f of g of x, means it is one function of inside one more function of x will be there. That is the meaning of it. Then you have to take actually g of x as u. Then you can take dy by dx is equal to, in this form only if you want to take f dash of g of x into g dash of x. This is called chain rule. Okay? Right? Whereas here if you can take y is equal to f of u of x or f of u, then this can also be taken as the other way. If y is equal to f of u, where u is also a function of x, or f of u of x, then u of x, then dy by dx can be taken as dy by du into du by dx. This you can call it as chain rule. Right. As I said, while looking here, it looks kind of different way of expression. While doing examples, you can feel it will more easy. So how we can apply this while doing the examples or questions? Let us see few examples.
Sir, what are difference between f dash and f in values, sir?
Yes, that's what we'll see with examples. Right. So can I analyze this? If you take example, if y is equal to log of e power x, log of e power x. So this is similar to what? F of one function of another function of x. First function is logarithmic function. Second function is exponential function. Two functions are there. Is it clear? So in such case, then find dy by dx. What is dy by dx is the question. So here, according to this, that both are same actually. You can take e power x as u. You can take this one way, different directly also can do, or you can take this inside function as u. U is equal to e power x. Then what will you get? Then y is equal to log u. Did you understand? Log u is as a function of x. Right? First step. Second step, from this dy by dx is equal to dy by du into du by dx. First, dy by du, this is your function. With respect to u, if you differentiate, you get d by du of log u. D by dx of log x is 1 by x. D by dx of log x is 1 by x. You can write here side. D by dx of log x is what? 1 by x. In place of x, if you take u, d by du of log u, what do you get? 1 by u. So d by dt of log t, 1 by t, like that. So but here dy by du is d by du of log u is 1 by u. This is what? 1 by u. Is it clear? But u is e power x. At the end we have to substitute that into du by dx. U is e power x. So d by x dx of d by dx of u is e power x. What is this? E power x only. So e power x. So now you take in place of du by dx here e power x as it is. Now you substitute u. It is equal to 1 by u is e power x into e power x cancel, you will get 1. Is it clear? So it is equal, therefore d by dx of log of e power x is equal to 1. Is this clear now? What is the meaning of f of x, g of x, what is the y equal to f of u? Right? So while doing examples, we get more clarity. If you look at the formula, you may think what is this, what is that. It may confuse. But while doing example, things will become clear, more clear. I will give one more example. Finish with this?
Yes, sir.
Another example. Let us take another example. Right. If y is equal, directly can take find d by dx of e power 2x square plus 3x is equal to what? So first function is exponential function, e power this, but this is again function of what you call polynomials. You can say x components, power functions we get, sum of power functions. So this secondary function, this is primary function. A secondary function you can take it as u, right? So you can take let u is equal to 2x square plus 3x. First step. Here, then what will you get? Then you can take it as actually y is equal to e power u. E power u. Now dy by dx is equal to, this is y, the entire thing you can take it as this entire thing is what? Y. dy by dx is dy by du into du by dx. Right? So this is equal to y in terms of u is e power u. The d by du of e power u is e power u only. So e power u only into d by dx of u is d by dx of 2x square plus 3x is 2 into x square differentiation is 2x. So 2 into 2, 4x. So this you can write it as, here side you can write separately. Then you can substitute if you want. D by dx of 2x square plus 3x is equal to d by dx of 2x square is 4x plus d by dx of 3x is 3. So that is what? Du by dx. So you can take this as 4x plus 3. But now substitute u. What is u? 2x square plus 3x. So now therefore you will get e power 2x square plus 3x into 4x plus 3 or 4x plus 3 into e power s. It will be your final answer. Got it? Yes. Good now. Therefore, this is your d by dx of e power 2x square plus 3x is equal to this. Okay? Next. Let us do one or two examples based on this differentiation. Then let us switch into integration part. Okay? Yes. Let me give you few examples, simple examples. So d by dx of, write down, d by, directly can do it quickly. D by dx of root x is equal to what?
X power minus 1 x power.
First we have to write x, root x means x power half. You have to apply power rule. So it is equal to d by dx of root means x power 1 by 2. So x power n formula I have to use. N into x power n minus 1. So 1 by 2 into x power 1 by 2 minus 1 is 1 by 2 minus half is minus 1 by 2.
1 by root x.
So we will get 1 by 2 root x. 1 by 2 root x. Then this also you can remember as a formula. Differentiation of root x is 1 by 2 root x. Okay? But you have to apply our rule only for this. Next. D by dx of sin 5x into cos 3x. Sin 5x cos 3x. Both are trigonometric functions. It is u into v formula I have to use here. U is sin 5x, v is cos 3x. Yes? So what we get? UV formula, product rule. So u into dv by dx. So sin 5x into d by dx of cos x. Cos x is minus sin x. But inside here we have 3x. So we have to differentiate that as by using what? Chain rule. Into differentiation of 3x will give you 3. So by step you want or directly you can do it. Yes? Step by step? See here. Let us take this as u. U is equal to sin 5x. V is equal to cos 3x. Vu is, this means what is du by dx? Du by dx is d by dx of sin 5x is cos 5x into differentiation of this. 5x differentiation is 5. So into 5 or 5 we can write here. 5 cos 5x is du by dx. Is this step clear? Next, v is cos 3x. dv by dx. dv by dx is d by dx of cos 3x. d by dx of cos x is minus sin x. But inside we have 3x. So it is minus sin 3x but differentiation of this is into 3. So 3 you can write, minus 3 sin 3x. So now write the formula, then substitute. What is that? U into dv by dx plus v into du by dx. Cross multiply. So u is sin 5x into minus this. So you can write directly minus 3 sin 5x. This cross multiplication of these two functions. Minus 3 sin 5x into sin 3x. Into sin 3x. Next plus cross multiplication of this. V into du by dx. V cos 3x into 5 cos 5x. So we'll get here plus 5 cos 3x into cos 5x. Got it? That's it. The two functions may be, one is exponential function, another one trigonometric or logarithmic, or both may be logarithmics, or both may be trigonometric, or both may be polynomial functions. Either way can be. Okay. So this kind of questions will come based on differentiation. So I will give you few questions at the end. The days colors, I will send few questions in WhatsApp. Tomorrow I will give, because you have tomorrow also, right? You can practice tomorrow. Then you can, if you have any confusions, we will discuss tomorrow based on differentiation. Right? Next, integration. Let us see quickly few integration relations. Right? Can I erase this? Next, note down. Right. Integration. So in a simplest way, integration can be termed as reverse process of differentiation. What is that? Reverse process of differentiation is called integration. Right now, reverse process of differentiation is called integration. Why or how can you say? If you observe the formula, then you can realize that. To understand that, let us write the list of formulae once again, the differentiation formulae, and let us try to write some formulae for integration. So first, constant differentiation formula, leave it. Then polynomial function we have, right? D by dx of x power n. What is this? N into x power n minus 1, right? So here, actually d by dx is called a differential operator. We are operating this on that function. So it is differential operator. Same way, we come across one operator in case of integration. That integral operator is represented as this. Integration symbol is this. So integral of that function. If you integrate that, we will get this. So this is what do you call it? Reverse function. Reverse functions. Integration is what? Reverse operation of differentiation. So if you integrate this, we will get this one. So according to integration, integral of x power n dx. That means if you are integrating x power n with respect to x, then it is equal to x power n plus 1 by n plus 1 plus c, where c is called constant of integration. Constant of integration. Right? But in integration, this is applicable for all values of n, just like that. Here, you can take x, n is equal to 0, 1 to 3 and so on. Similarly here also, but except one value, you can take n, any value, but even positive, negative, any values, provided n cannot be equal to minus 1. This is not applicable for n equal to minus 1. for any other values, n equal to minus 2, minus 3, minus 4, minus so on, and n equal to 1, 2, 3, 4, and so on. Any fraction values, for all values it is applicable, except n is equal to minus 1. Because x in place of n, if it is minus 1 is there, x power minus 1 can be expressed as 1 by x. So the integral of 1 by x dx is given as log x plus c. So if you compare this here, x power n is equal to n into x power n plus n minus 1, right? So if you take, what is that? Integration of that, n into x power n minus 1, x power n plus 1 by n plus 1. N is a number, keep that aside. N minus 1 plus 1 by n minus 1 plus 1. What do you get? X power n by n. N cancel, you get x power n. So that's why it is called reverse process. So similarly, if you have differentiation of d by dx of log x, what is d by dx of log x? 1 by x. So integration of 1 by x is log x. Reverse. Integration of 1 by x is log x. Reverse. Got it? Similarly, differentiation of e power x. What is this? E power x only. So if you integrate that, we get the same function. That means integral of e power x dx is equal to e power x only plus c. For every operator here, we will get plus c plus c plus c. We call this as what do you call? Integration constant. Constant of integration.
So what is integration of log x?
Integration of
Log x.
log x. Usually for log x we will get an expansion series we have to apply. Directly we will not get. So like sin x expansion, cos x expansion, like series expansions we get. That we have to use. Okay. So here direct formula we will not use. So that's why we are taking this way. Right. Next. Let us take trigonometric functions. So d by dx of sin x. What is d by dx of sin x? D by dx of sin x
Minus cos x.
is plus cos x. Differentiation. Cos x. Right? So if you integrate that, you will get this one. So integral of cos x will be sin x. So similarly, d by dx of cos x is what? Minus sin x. So here, if you integrate sin x with respect to x, then the negative sign will come this side and it becomes minus cos x. So this, you have to remember it as integral of sin x dx is equal to, sin x if you integrate, negative sign comes here and it becomes minus cos x plus c. Similarly, integral of cos x dx is equal to plus sin x plus c for cos x plus sin x. For sin minus cos, integration. So this you have to remember. Differentiation of sin is plus cos. Cos is minus sin. Sin cos. Cos minus sin for differentiation. Integration other way. Sin will also change. For sin, there positive sign. Integration, negative sign will come. Integral of negative, what you call, sin x dx is minus cos x. Whereas integral of cos x is plus sin x. Got it? Then, so differentiation of tan x. D by dx of
Minus
tan x plus secant square x. Secant square x. You will not write plus sign. That means positive. So if you integrate this, you will get this one. So that means, next you can write down here. You can erase this. So integral of secant square x.
minus tan x.
So integral of secant square x dx is what?
Minus tan x.
Why minus? What is there? Is there any minus? Tan x only. Right? Minus tan x. Minus? Plus only. Plus tan x. It is the reverse process. Differentiation of tan is secant square x. So integration of secant square is plus tan x. Plus tan x. So no need to give sign. So tan x. Got it? Similarly, d by dx of cot x Yes, here minus will come. Minus cosecant square x. So if you integrate this, minus sign comes here and it gives you minus square x. So integral of cosecant square x dx will give you what? Minus cot x plus c. Got it? And usually we will not come across integral of tan, integral of cot. So that you have to change accordingly. Got it? So if you come across this, you have to change into secant square form. If you come across this, you have to change into cosecant square form. How? We have this trigonometric identities. Sin square x plus cos square x is equal to 1. Tan square x minus secant square is equal to 1. So from those relations you have to change the functions, then you have to do it.
Sir, for integral of sin x we are putting minus cos x.
Yes. From that.
Sir, but there is 2 6 at plus 1 because plus sin d by dx of sin x is equal to plus cos x.
Plus cos x.
Yes.
Integral of cos x
Sin minus
plus
sin. Sir, but here we are putting minus.
for integral of cos.
Yes.
Did it give minus? For integral of cos? No. For sin. So here, this one, integral of sin, the negative sign will come here. Okay? Accordingly, sign will change. Yes? So these are integration formulae of few trigonometric functions. Right? Here, this u by v rules we will not use, but chain rule we will use, provided if you come across that chain function, that is an internal function, in differentiation of first function into differentiation of that internal function we will do. But in integration of first function divided by differentiation of internal function we have to do. That difference we have to do. So that is the form of chain rule in case of integration. Let us see how to express that. Can I erase this one? Let us say integral of, with some example, instead of taking the general formula, let us take, or if you say general formula, if you want to take integral of f of, only f of x means that f dash x can give you integration, but f of x, f of g of x if you have, into dx, then f dash of g of x I have to take divided by g dash of x. This you have to understand properly. In differentiation, into g dash x we will take, but in integration, divided by g dash x we have to take. Is that clear? So you can let us understand this by using some examples. This is special. Right? Can we take some examples? Take integral of let's take sine of e power x, dx, or e power 2x dx, sine of e power 2x dx. So how can you do this? Integral of the first function is sine function, trigonometric function. The internal function is exponential function. So first you have to integrate the first function. The function as it is you have to take e power 2x divided by
e power 2x.
Differentiation of that internal function. Differentiation of e power 2x is differentiation of e power 2x. Again there you have to use chain rule. So otherwise you can write like this. U is equal to e power 2x. Then you can write integral of, if you write this, then you have to take this differently. E power sin u du you have to take. Okay? So then you have to take sin u du you have to take. then sin u du, because the integration with respect to the parameter variable as actually here this is okay. Even if you take this as with respect to x, because u is a function of x. U is a function of x. So you can write sin u dx only. But here u is a function of x. So you have to take this as it is equal to sin of u of x gives you minus cos of u of x. Sin of u of x dx is equal to cos of minus cos of u of x divided by du by dx. You have to take du by dx. Right? That du is e power 2x. So separately, if you can write d by dx of e power 2x is the differentiation of exponential function is same, e power 2x only. But here again one more function is there, that is into 2. So that will come here. It is equal to 2 into e power 2x. So minus cos e power 2x divided by 2 e power 2x. Got it? So this you have to understand step by step. Into 2, this can be expressed as 2 into e power 2x. This you have to take in place of du by dx. Okay? So in integration, the integral function differentiation part you are taking denominator. In differentiation of integral function will be taken as product. Here as a ratio, division you will take. That difference. Right? Can you do one more example? One more example? Yes. I'll give you a simple formula. So integral of x power 4 plus 2x plus 2x dx. A simple direct relation. So what you will do here? Polynomial power rule, right? You can apply power rule. There is no chain rule. Simply you can write it as, if you have sum of two functions, you have to apply sum rule. Integral of this plus integral of this. So you can write it as integral of x power 4 dx plus 2 into integral of x dx. So it is, what do you get?
Sir, x power 5 by 5x plus x square.
Integral of x power n dx. You can write the general formula. Integral of x power n dx is what? X power n plus 1 by n plus 1. So it is 4 plus 1, 5. X power 5 by 5 plus 2 into x square by 2. 2 cancel. So you get x power 5 by 5 plus x square. Or even you can take x square common and you can write x cubed by 5 plus 1 x square into. This way also you can write. Okay? So some rules. Usually this kind of simple questions will come. So just for having an idea of how to apply integrations. But in physics, usually we apply these integrations with limits sometimes. So all these integrations are called indefinite integrals. If integration is coming with a limit, we call it as definite integral. Definite limits will come. So if at all if you have integral of f of x dx with the limits a to b, if you come across, then you have to write this as f dash of x with the limits as a to b. Here a is called lower limit, b is called upper limit. In such case, you have to apply first upper limit, that is f dash of b minus lower limit you have to apply, minus f dash of a you have to apply. This gives you what you call integration of what definite with limits, integration with limits. We call it as definite integrals. This kind of integrals are called definite integrals. Let me give you a few simple examples. Integral of x square dx, where x goes from 2 to 3 is equal to what? So x square dx is what? X cube by 3. X cube by 3. X power 2 plus 1 by 2 plus 1. So x cube by 3 with the limits 2 to 3 means first you have to apply upper limit minus lower limit. So in place of x you have to put that upper limit first, means 3 cube minus 2 cube by 3. 3 is common, actually you can take this 3. So 3 cube minus 2 cube. 3 cube is 27. 2 cube is 8. So 27 minus 8 by 9. How much? 19 by 3. So this you have to take directly. 19 by 3. Is it clear? So this is how you have to apply integrals with limits or finite integrals. In place of this you can have exponential function or trigonometric function, any function. But if you have trigonometric functions, the limits will be in the form of degrees or radians. So let us see one example here. Integral of sin x dx with limits from pi by 2 to pi is equal to what? Integral of sin x is what? Minus cos x. Minus cos x. Now put the limit. Lowest pi minus cos pi by 2. Minus are taken out. Okay? So what is cos pi? Cos pi here are 180 degree. Pi radians is equal to 180 degree. Cos 180 or cos pi is minus 1. So this you can write it as minus of, this is minus 1 minus cos 90. 0. Cos 90 is 0. So minus 1 minus 0 is minus 1. Minus of minus plus 1. So this is equal to plus 1. So you get numerical value. Got it? So these kind of questions also will come. So here the limits can be given as in radians or degrees also for trigonometric functions. For other exponential, logarithmic and normal polynomial functions, usually normal values are in integral limits or decimal limits or fractional limits also can be given. Got it? So these are briefly few examples related to the important rules of differentiation and integration. Right? Now, if you have already any questions, you can bring so that we will discuss those. Do you have any questions? Let me check. Anyone, online students are mentioning some questions? Cos pi is minus 1. We have discussed what do you call trigonometric values, trigonometric ratios of standard angles. Sin 30, sin 60, sin 45, sin 90, cos 30, cos 45, cos 60, cos 90. So these angles you have to remember. Okay? Trigonometric tables, tan, cot, these values. So if you didn't remember, I will give you one simple idea to remember this one, especially few standard angles. Remember, for sine or cos, sit down. You can remember, do you know how the sine wave and cosine wave looks like? Yes? Yes. If not, here onwards, you remember this for remembering the values, trigonometric values. Sine wave, this wave, this shape is called sine wave. Right? If we take the angle on x-axis and the function, sine function, this is y is equal to sine x, this is sine wave. Sine wave starts from 0. Okay? So this is, let us say, you can take time or angle. In terms of angle, let us take. This similar things will come across in what you call in simple harmonic motion. In simple harmonic motion, sine omega t or sine of the theta, angular displacement can be taken as in terms of omega t. The time period we will take. There we can understand differently. See here, this will be taken as 0. The angle in theta in radian you can take, let us say, in radian or degrees also you can take. So theta, this is pi by 2 radian, this is pi radian, means pi by 2, 2 pi by 2 can be taken as pi, this will be 3 pi by 2 radian, this is 4 pi by 2 or 2 pi radians. Pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2 radians. Or in degrees, 0 degrees, 90 degrees, 180 degrees, this is 270 degrees, 360 degrees. So sine 0, 0. This maximum value of sine will be plus 1 and this minimum value is minus 1. Sine value will varies between plus 1 and minus 1. So sine 90 or pi by 2 is plus 1. Sine 180, 0. Sine 270 or 3 pi by 2, minus 1. Right? Sine 360 or 2 pi, 0. This is how you can remember the values, trigonometric values. For sine. For cosine also the same way you can remember. Cos function will be, for sine 0, it will be 0. But cos function will be, for cos 0 it will have maximum value. So cos wave can be drawn like this. So this is for 2 pi only. This is for 0. This is cos x or cos theta. Theta, that will be theta. This is x, that will be x. So this is theta. Or if you take it as x, cos x, this you have to take it as x. Or if it is cos t, that you have to take t, depending on the variable. So cos 0 will be plus 1. This is pi by 2. Cos pi by 2 is, cos 90 degrees is 0. Cos 2 pi by 2. 2 pi by 2 means pi. Cos pi is minus 1. Cos pi is minus 1. Or cos pi or cos 180 is minus 1. Cos is pi 2 pi by 2. Sorry, 3 pi by 2 is 0, then it is 2 pi. Pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2 for cos. So cos 0 is 1, cos 90 is 0, cos pi is minus 1, cos 3 pi by 2 is 0, cos 2 pi is plus 1 again. This is how you can remember sine and cosine functions, trigonometric ratio values. Similarly for tan, but tan is it goes to infinity, for plus or minus what you call 0 and 2 pi, because tan theta is sin theta by cos theta. Sin 0 is 0 and so you can take it as it will varies from 0 to infinity. Tan goes from 0 to infinity because sin 0 by cos 0 is what? 0 by 1, it will give 0. But 90, sin 90 by cos 90. Sin 90 is 1, cos 90 is 0. So it will 1 by 0 gives infinity. Indeterminate value you can take, otherwise infinity. So you can take it as it goes to infinity. Indeterminate, undefined. So it will say tan values varies between, like you can take 0 and 90. You can take the graph. Tan graph. It will be like it goes to infinity. So we will not consider about that. Only these two, if you remember, this will be more useful while dealing with physics, trigonometric ratios in physics. Okay. So these are briefly some important relations of differentiation, integration. So now, do you have any questions? So you note down this waveforms also, so that you can remember this, you can recollect back easily. You can find out the values while doing this integrations. This is sine function, this is cos function. Okay? Now, as already the brief revision is done. Now let me give you some questions, simple questions to check your understanding. Okay? Right? Can I raise these forms, waveforms? Everyone? Right. Next example. First, integral of 1 by x dx with limits 2 to 3 is equal to what? Integral of 1 by x dx is what first? So it is equal to log x with the limits. If limits are there, no need to write plus c. If limits are not there, then only have to write plus c. Okay? So now limits are 2 to 3. So what will you get? It is equal to log 3 minus log 2. You can keep as it is. Sometimes in the options it will be mentioned as log 3 by 2. So first is log a minus log b can be written as log a by b. Here you have to use one formula. Log a minus log b can be expressed as log a by b. So no base means base c you have to take. That's it. Fine. Yes. Another relation. Another relation. Right. So, in differentiation, let me give you one more additional formula in differentiation. In differentiation, we have discussed that d by dx of e power x is what? E power x only. Right? If something is there inside in the exponential part, you have to use plus chain rule. Whereas instead of e power x, e is a number. Exponential value will be having some 2.71 something like that power x. Right? Instead of that, if you have d by dx of a power x. So like 2 power x or 3 power x, 4 power x, like that. X into it is not a polynomial function. If it is x power n, then you can take n into x power n minus 1. It is different kind of function. In these kind of cases, you have to take like this. This function as it is a power x into log a base e. Base nothing is mentioned, means base e only. So a power x into log a you have to take. Is it clear? This also write down, this formula also. This I have not given while giving the list of formulae. So here in place of a you can have any number. Let us take one example based on this. D by dx of 2 power x is equal to what? D by dx of 2 power x is equal to what? 2 power x into log 2. Log 2. But log 2 base e, sometimes you have to remember, especially this you will make use in 12th standard in nuclear chapter we come across that for some conversion relation. Log 2 basic and integral is 0.639. So that will be, if you remember, you can write it as 0.639 into 2 power x, otherwise you can keep that as it is, no problem. Okay? So this is how you get it. This is another formula you have to remember. d by dx of a power x is what? A power x into log a, or log a base e. A power x into log a base e. Is it clear? Right? Next. Take this relation quickly. Both together, differentiation and integration together. Let us do some examples. We have just 10 minutes time up. We have 10 minutes? 5 minutes. Okay. So d by dx of d by dx of sin 2 pi x plus pi by 3 is equal to what? d by dx of this is equal to what? What rule? Chain rule. Yes, what rule? Chain rule. According to chain rule, d by dx of sin, whatever may be inside, d by dx of sin is cos, blindly, cos of entire thing. What is that? 2 pi x plus pi by 3 as it is. Then differentiation into differentiation of the integral function. What is integral function? 2 pi x plus pi by 3. Differentiation of this is what? This is sum of two things. 2 pi x plus pi by 3. Pi by 3 is, it is a function of x. Here is any x is there? No. So it has to be taken as constant. So differentiation of this will be 2 pi. Very good. Is it clear? So into 2 pi. Into 2 pi. So you can write it as 2 pi into cos 2 pi x plus pi by 3. That's it. Yes? Next. Another question similar to this. Take down. D by dt of, here the variable is dt, t. D by dt of tan pi by 2t plus pi by 6 is equal to what? As differentiation of tan is? Right. Blindly, right? Secant square of the entire function first. So it is equal to secant square entire function. What is that? Pi by 2t plus pi by 6. Then into differentiation of inside function. What is that? Differentiate with respect to t. So pi by 2 plus this, for this is 0. So into pi by 2. Into pi by 2. That's it. Or pi by 2 into that. Got it? So this is how you have to do differentiation in some cases. It's clear? So most commonly you will get differentiation of polynomial functions and product rule, quotient rule and chain rule. If these are clear, so all questions may come based on this in differentiation. In integration, and of course in those you have to remember differentiation of what you call x power n form, log x form, e power x form, trigonometric ratios. Similarly in integration also, you have to remember the basic relations. In the integral of x power n, integral of e power x, right? Integral of 1 by x, integral of trigonometric functions. So you can take, you have did this, right? Similar to this, we'll do one last example, then we'll wind up. Integral of 1 by 2x plus 3 dx, where x goes from 1 to 2. is equal to what? Is equal to what? So integral of 1 by x is log x. In place of that, if you have this kind of form also, you have to take log of that first. So log of this, what is this? Log of 2x plus 3. If it is only x, that log x and the limits you can apply. But here, because it is based on chain rule, divided by differentiation of this. Divided by differentiation of this. What is that? Differentiation of this? 2. So divided by 2. Now you apply limits for the entire thing. Lower limit is 1, upper limit is 2. 2 is number, take it out. So you can take this as 1 by 2 into log of place of 2 x first upper limit. 2 into 2, 4. 4 plus 3, 7 minus in place of x lower limit log of 2 into 1, 2. 2 plus 3, 5. Log 5. So it is equal to 1 by 2 into log 7 by 5. Got it? That's it. So this kind of questions will come.
So what is integration to constants? Integration to constants.
Integration of constant. Integral of some constant into dx. So this can be taken as you have to take constant out and you have to write integral of dx. Integral of dx means x power 0. 0 x power 0 plus 1 by 0 plus 1. That means x. Constant will come as d into x. Cx. Okay? Yes? So these are some general questions. Practice this with good days. So it's not here?
So days case.
Yes, color. Okay, I'm winding now. Right, you practice again like tomorrow. You can re-revise and we'll discuss briefly about you can revise about the types of vectors on the other track, and you can be thorough. I want everyone to score in physics at least not less than 100 out of 180. Okay, out of 45 questions, everyone should answer more than 25 questions minimum. So if you do out of out, this is well and good. Right? Physics you have to be perfect. Okay then.